Hi, welcome back to Full Stack Open Curriculum. We're gonna continue on with part 1D, a more complex state and debugging React apps. Complex state. In our previous example, the application state was simple as it was comprised of a single integer. What if our application requires a more complex state? In most cases, the easiest and best way to accomplish this is by using the useState function multiple times to create separate pieces of state. In the following code, we create two pieces of state for the application named left and right that both get the initial values of 0. Okay, so we can go into here and then change our app component. Change our app component to this. And then get rid of these two lines of code here. Okay, cool. So the component gets access to the functions setLeft and setRight that it can use to update the two pieces of state. So if we run this, let's go to cd part 1 temp. What's the script here? So it's dev pnpm dev. Let's go to localhost 5179. 73. We have left and right. So that's the app. The component gets access to functions setLeft and setRight. Okay, so the components or a piece of state can be of any type. We can implement the same functionality by saving the click count of both the left and right buttons into a single object. In this case, the application will look like this. So if we copy it like this, then we have essentially one piece of state that's a bit more complex as an object. And then we have handle left click, a click handler, and another one, handle right click, and that handles each different click. And we attach it to the button here. So if I save, go back to the app, it should look exactly the same. Now the component only has a single piece of state that the event handler have to take care of changing the entire application state. The event handler looks a bit messy. When the left button is clicked, the following function is called. The following object is set as the new state of the application. The new value of the left property is now the same as the value of left plus 1 from the previous state. And the value of the right property is the same as the value of the right property from the previous state. So it's essentially just saying that this is the new state and it's the old state, except that for left, you add 1 to it for this property clicks.left, the value of this property on the state object. The new value of the left property is now the same as the value of the left plus previous state, and the value of the right property is the same value of we can define the new state object a bit more neatly by using the object spread syntax that was added in the language specification in the summer of 2018. So we can just do handle left click like so. And then handle right click. So that just means spread the old state, which is here, into this new object, and then overwrite the left property with this, which is just the old property of value plus 1, overwrite this part here. And this is the same for the handle right click as well. So the syntax may seem a bit strange at first. In practice, ... clicks creates a new object that has copies of all of the properties of the clicks object. When we specify a particular property, e.g. right, like so, the value of the right property in the new object will be 1. In the example above, this is clicks, ... clicks, and then right, clicks.right plus 1. Creates a copy of the clicks object where the value of the right property is increased by 1. Assigning the object to a variable in the event handler is not necessary, and we can simplify the function to the following form. So rather than assigning these new clicks here, we can simply do this, like so. It's the same object, we're simply just not needing this variable. And since all this function it does is one sec. So yeah, so now we have it like this part here, this part of the code. Oops. Some readers might be wondering why wouldn't you just update the state directly like this. So rather than, instead of using set state, we just increment clicks.left. The application appears to work, however, it is forbidden in React to mutate state directly. So this is very important. Whenever you want to update state, never just change the state itself. You need to use the update function, since it can result in unexpected side effects. Changing state has to always be done by setting the state to a new object. So if you want to learn more about this, this Stack Overflow answer provides the reason as to why you don't want to update state directly. So if we go back, changing the state has to always be done by setting the state to a new object. If properties from the previous state object are not changed, they need to simply be copied, which is done by copying those properties into a new object and setting that as a new state. Storing all of the state in a single state object is a bad choice for this particular application. There's no apparent benefit for resulting in a lot more complex. In this case, storing the click counters into separate pieces of state is a far more suitable choice. There are situations where it can be beneficial to store a piece of application state in a more complex data structure. The official React documentation contains some helpful guidance on the topic. Okay, so handling arrays. Let's add a piece of state to our application containing an array or clicks that remembers every click that has occurred in the application. So now, as you can see, they've gone back and changed it back to separate pieces of state and added an all clicks one that will remember all the clicks that have been made in the application. So if I copy this and then I add it into the app, like so, every click is stored in a separate piece of state called all clicks that is initialized as an empty array. So here is where it's being initialized as the empty array. Const all clicks set all, it's just this line here. Handle left click is what it's doing is first it's updating the all click state to add an L, which represents a left click, to the array, and then it increments left to +1, which will then be shown in here. Oh no, sorry, it will be shown. Let me just go back to the code. Yeah, so here as you can see, as I click left, this all state gets rendered here, and then this part here is the actual number of times that left has been clicked. Okay. So the piece of state stored in allclicks is now set to be an array that contains all the items of the previous state array plus the letter L. Adding the new item to the array is accomplished with the concat method, which does not mutate the existing array but rather returns a new copy of the array with the item added to it. In other words, some array methods shouldn't actually be used when doing this because it'll mutate the original state. We want to use array methods that create a copy of the allclicks state and then returns a new array. As mentioned previously, it is also possible in JavaScript to add items to an array with the push method. If we add items to the push to the allclicks array, then updating the state, the application will still appear to work. So this is what I'm talking about when I mean that, like, you don't want to use push because it actually changes the old state. However, don't do this. As mentioned previously, the state of React components like allclicks must not be mutated directly. If mutating the state appears to work in some cases, it can lead to problems that are very hard to debug. Let's take a closer look at how the click is rendered to the page. So this is the part where it takes the array that's allclicks, and then it joins each left or R, and separates each one with a space. We call the join method on the allclicks array that joins all the items into a single string, separated by the string passed as the function parameter, which in our case is an empty space. Update of the state is asynchronous. Let's expand the application so that it keeps track of the total number of buttons pressed in the state total, which is the value always updated when the buttons are pressed. So this is probably my guess is the number of times the buttons are clicked. So if we have const total set total set total left plus right, copy this, so let's see what happens here. Oh wait, actually we had to render the totals, so we see what that is. Okay, so let's have that here. Start the application. Interesting. So notice how the total actually lags behind 1. So when we start, it's 0 and the total is 0. But then if I click left, these get counted as 1. Total actually gets counted, but it actually renders as nothing first. And it's only when the next click that it renders the old state. The total number of presses is consistently 1 less than the actual amount of presses for some reason. Let's add a couple of console log statements to the event handler. Okay, so let's go left click. So this is just seeing the number of what left state is. So you can imagine when left is set, you think that it would increase here. So left before should be like, for example, 0, and when it's clicked, it should be 1. But as you can see, that's not the case. So if I restart again, it doesn't actually increase immediately. The console reveals the problem. Even though a new value was set for left by calling setLeft +1, the old value persists despite the update. As a result, the attempt to count button presses produces a result that is too small. The reason for this is that the state update in React happens asynchronously, i.e. not immediately but at some point before the component is rendered again. We can fix the app as follows. So here, if we create a variable called const updated state left equals left +1, and then we set left as updated left, and rather than adding left plus right, we add updated left plus. Then this should work. The reason is, rather than letting it be left +1 where we rely on the new state, we're actually saving the updated value into a variable and having that immediately be executed in memory. So now the number of button presses definitely is based on the correct number of button presses. We can also handle asynchronous updates for the right button. So if we do the same thing for the right button, just copy this here, and then instead of updated left, we do updated right, and then updated right. Now it should work as expected, and it does. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, great. Now the number of button presses is definitely based. Okay, yep. Conditional rendering. Let's modify our application so that the rendering of the clicking history is handled by a new history component. So we refactor this. If we have history, let's see here, history, rather than, we just have, instead of this, we have history, all clicks. Total is no longer used. So we can, for now, remove that piece of state. So this has to do with ESLint. We can actually disable this. I think the easiest way is just to use, one sec, let me just try this. So if I get it to disable ESLint, in the ESLint settings, there we go. So if we copy this, let's just copy this line here, and in ESLint config rules, let's just add this part here. Yep, so this, yeah, so now you can see it's no longer complaining of this props. We then remove this state because we no longer use the totals. Actually, let's leave it back in. Updated, right? Updated. Okay, cool. So now the behavior component depends on whether any buttons have been clicked. If not, the meaning of all clicks is empty. The component renders a development with some instructions instead. So the idea is right at the beginning, when all clicks is empty, this div gets rendered because the length will be 0. Otherwise, show this, which is what we had before, except it has a little bit of information, a little bit of text before the actual number of all clicks. So if we go back here, as you can see, right at the beginning, because all clicks is 0, the length of all clicks is 0, it's an empty array. This is an empty array. We show this div here. As soon as we click one button, it shows the button press history. Okay. The history component renders completely different React elements depending on the state of the application. This is called conditionally rendering. So the conditional rendering is happening here due to the if conditional. React also offers many other ways of doing conditional rendering. We will take a closer look at this in part 2. Let's make one last modification to our application by refactoring the button component that we defined earlier on. What is the button component? Here it is. It's here. So if we refactor this out. So this is a button component with the onClick handler and the text, which is passed like so. And then here, instead of using the HTML button element, we use button, the component. On click still uses handle left click, and we have we passed the text to left like so, and have it as a self-closing component. So we can do that as well for the right button. Instead we have handle right and text as right. Okay, cool. And as you can see, the app remains the same because it's a simple refactor. Old React. In this course, we use the state hook to add state to our React components. So state hook is basically this use state hook. So this is a function component. That's why we use state hooks like this, which is part of the newer versions of React and is available from version 16.8.0 onwards. Before the addition of hooks, there was no way to add state to functional components. Components that required state had to be defined as class components using the JavaScript class syntax. So if we go to here, component, this is what a component looks like as a class component. So we declare what the name of the component here, and then this is where we render out the JSX. And so like the business logic usually happens between the first line and the second line, the render function here. Yep, so as you can see, this is where it does some of the logic. And then this is the context type. Oh, actually, yeah, so the logic actually happens in the render function before the return statement. In this course, we have made the slightly radical decision to use hooks exclusively from day one to ensure that we are learning the current and future variations of React. Even though functional components are the future of React, it is still important to learn the class syntax, as there are billions of lines of legacy React code that you might end up maintaining someday. The same applies to documentation and examples of React that you may stumble across on the internet. We will learn more about React class components later on in the course. So if we go to 16.8.0, as you can see, it was published 6 years ago. So essentially, class components was how people mostly wrote React 6 years ago. Yeah, so it's quite a while ago, but there are code since React is like, I think 12. It's been around for 12 years. So there's definitely old code with class components that's existing in production applications. Debugging React applications. A large part of the typical developer's time is spent on debugging and reading existing code. Every now and then we do get to write a line or two of new code, but a large part of our time is spent trying to figure out why something is broken or how something works. Good practices and tools for debugging are extremely important for this reason. Lucky for us, React is an extremely developer-friendly library when it comes to debugging. Before we move on, let us remind ourselves of one of the most important rules of web development. The first rule of web development: keep the browser's developer console open at all times. Yep, so this is the browser's developer environment. The console tab in particular should always be open, unless there is a specific reason to view another tab. Keep both your code and the web page open together at the same time, all the time. If and when your code fails to compile and the browser lights up like a Christmas tree, like so, do not write more code, but rather find and fix the problem immediately. There has yet to be a moment in the history of coding where the code that fails to compile will miraculously start coding after writing large amounts of additional code. I highly doubt that such an event will transpire during the course either. Old school print-based debugging is always a good idea. If the component, so this is the component, is not working as intended, it is useful to start printing its variables out to the console. In order to do this effectively, we must transform our function into a less compact form and receive the entire props object without destructing it immediately. This will immediately reveal if, for instance, one of the attributes have been misspelled when using the component. Okay, so note, when you use console log for debugging, don't combine objects in a Java-like fashion by using the plus operator. Because then this will concact. If you do that, you'll end up with a rather uninformed log message. Props value is object. Instead, separate the things you want to log to the console with a comma. Yeah, so rather than use plus to console out variables, use a comma instead. In this way, the separated items will all be available in the browser console for further inspection. Logging output to the console is by no means the only way of debugging applications. You can pause the execution of your application code in the Chrome Developer Console's debugger by writing the command debugger anywhere in your code. The execution will pause once it arrives at the point where the debugger command gets executed. So, if we write debugger here, as you can see, if I rerun the application actually pauses right here. So then we can check, for example, with these variables in the console. They should equal the initialized values. So for example, if I do console.log all clicks, as you can see, it's an empty array, as expected. We can try another one for total. Total should be 0. Yep. So that's the usefulness of debugger. You can actually pause the application anywhere and then check what some of the values are during that point in the execution of the application. Okay, so if we just play through the debugger, it actually continues on to running the rest of the application. So let's just remove this debugger code. That's how the debugger works. Once the cause of the bug is discovered, you can remove the debugger command and refresh the page. The debugger also enables us to execute our code line by line with the controls found at the right-hand side of the Sources tab. You can also access the debugger without the debugger command by adding breakpoints in the Sources tab. Inspecting the values of the component's variables can be done in the Scope section. So if we go into the Sources tab, if we do, let's see, if I click, why can't I, so if I do this, then I'd refresh. Where is the, I can't seem to find the, so as you can see, it's paused and the return, but I can't seem to find the variables. I think it's because I'm using Firefox, so it's a little bit different. If I do scope, scopes, show original variables, there we go. Okay, so here you can see what the values of all the variables are. Yeah. You got left, right, all clicks, and total. So these are all functions. These two are functions that we've written here. And these are functions from the useState hooks. And then we have the state variables. Cool. Similar, we can run through and then it will continue running as before. It's highly recommended to add the React Developer Tools extension to Chrome and add the New Components tab to the Developer Tool. The New Developer Tools tab can be used to inspect different React elements along with their state and props. So let me just check if I can, do I have React? No, let me just check here. Firefox, React, Developer, Tools. There we go. Add to Firefox. Add. Okay. Now we should have, yep, so we have components. And it's similar to how it is in Chrome. We can go to history. Now if we click, we can see the variable with the state of the all clicks state. The add component state is defined like so. DevTools show the state of hooks in the order of their definition. So if I click app, yep, so state 4 is this piece of state here, this is piece here, and this is state is total. The first state contains the value of the left state, the next contains the right state, the last contains the value of the all-click state. You can also learn about debugging JavaScript and Chrome, for example, Chrome DevTools guide video. Yeah, so I'm using Firefox here, but it's pretty much the same as you can see with Firefox and drawn. Rules of hooks. There are a few limitations and rules that we have to follow to ensure our application uses hooks-based state functions correctly. The useState function as well as the useEffect function introduced later in the course must not be called from inside of a loop, a conditional expression, or any place that is not a function defining a component. This must be done to ensure that the hooks are always called in the same order, and if this isn't the case, the application will behave erratically. To recap, hooks may only be called from inside of a function body that defines a React component. Yes, so if this happens, it will not work because it's inside of the if statement. Oops, what did I just do? Okay, so inside of a if statement or a for loop, so or a function. Event handling revisited. Event handling has proven to be a difficult topic in previous iterations of this course. For this reason, we will revisit the topic. Let's assume that we're developing this simple application with the following component. Okay, this is quite a simple component. Yep. We want the clicking of the button to reset the state stored and the value variable. In order to make the button react to a click event, we have to add an event handler to it. So we'd have to add it to this button component, this button element here. Event handlers must always be a function or a reference to a function. The button will not work if the event handler is set to a variable of any other type. If we were to define the event handler as a string, React will warn us about this in the console. The following attempt will also not work. Yes, so it has to be a function. We have attempted to set the event handler to value plus 1, which simply returns the result of the operation. React will kindly warn us about this in the console. This attempt will not work either. Yes, so these are all expressions. The event handler is not a function but a variable assignment, and React will once again issue a warning to the console. This attempt is also flawed in the sense that we must never mutate state directly in React. What about the following? This message gets printed to the console once when the component is rendered, but nothing happens when we click the button. Why does this not work even when our event handler contains a function console.log? The issue here is that our event handler is defined as a function call, which means that event handler is assigned to a return value of the function from the function, which in the case of console.log is undefined. So if the call of console.log actually returns another function, then this will work because onClick always expects a function to be passed to it. Because even though this is a function, it's actually calling the function, which actually returns undefined. So as far as the this onClick is concerned, it's actually being passed in undefined. So the function call gets executed when the component is rendered, and for this reason, it gets printed once to the console. The following attempt is flawed as well. We have once again tried to set a function call as the event handler. This does not work. This particular attempt also causes another problem. When the component is rendered, the function setValue0 gets executed, which in turn causes the component to be re-rendered. Re-rendering in turn calls setValue0 again, resulting in an infinite recursion. Executing a particular function call when the button is clicked to it can be accomplished like this. So we can try this here to show what happens. Instead of set value, let's do setLef as 1 to see what happens when we actually do it like this. I just want to see what happens when re-rendering in turn calls setValue again, resulting in an infinite recursion. Yeah, so as you can see, React actually shows you the error. It says, uncle error, too many re-renders. React limits the number of renders to prevent an infinite loop. In other words, React actually recognizes this is an infinite re-rendering, and it'll actually stop from happening. Okay. So this is the correct way of doing it. Now the event handler is a function defined with the arrow function syntax. And when the component gets rendered, no function gets called and only the reference to the arrow function is set to the event handler. Calling the function happens only once the button is clicked. We can implement resetting the state in our application with the same technique. The event handler is now the function this. So it's a definition of a function essentially. Defining event handlers directly in the attribute of the button is not necessarily the best possible idea. You often see event handlers defined in a separate space. In the following version of our application, we define a function that then gets assigned to handle click variable in the body of the component function. Yes. So this is essentially a refactor where you bring out the console.log to an anonymous function and then assign it to this variable here. The handle click variable is now assigned to the reference of the function. The reference is passed to the button as an onClick attribute. Naturally, our event handler function can be composed of multiple commands. In these cases, we use the longer curly brace syntax for arrow functions. So when there's two or more lines, you can use the curly brace syntax. A function that returns a function. Another way to define an event handler is to use a function that returns a function. You probably won't need to use functions that return functions in any of the exercises in this course. If the topic seems particularly confusing, you may skip over this section for now and return to it later. Let's make the following changes to our code. So let's see. Here what is happening is it's defining a function that generates a function called handler and then running the first function that's defined. The code functions correctly even though it looks complicated. The event handler is now set to a function call. So you're actually running this function which then returns this handler function here. Earlier on, we stated that an event handler may not be a call to a function, and that it has to be a function or a reference to a function. Why then does this function call work in this case? Because the function call returns another function. When the component is rendered, the following function gets executed. The return value of the function is another function that is assigned to the handler variable. When React renders the line, it assigns the return value of hello to the onClick attribute. Essentially, the line gets transformed into this. Since the hello function returns a function, the event handler is now a function. What's the point of this concept? Let's change the code a tiny bit. Okay, so this part here is actually introducing you to a concept called currying. So what's the point of this concept? Let's change the code. So we have hello and we have who. So we can actually pass in a variable in the function that returns a function. Now the application has three buttons with event handlers defining the hello functions that accept the parameter. Yes, and the parameter is the parameter who. The first button is defined as hello world button. The event handler is created exiting the function call hello world, and the function call returns the function hello world. The second button is defined as hello react, so then it will console log hello react. Both buttons get their individualized event handlers. Functions return functions can be utilized in defining generic functionalities that can be customized with parameters. The hello function that creates the event handlers can be thought of as a factory that produces customized event handlers meant for greeting users. Our current definition is slightly verbose. So, in this sense, the hello function is the factory, and the handler is the function that gets returned. Let's eliminate the helper variables and directly return the created function. So we can do this. This is just shorthand for this. And since our hello function is composed of a single return command, we can omit the curly braces and use the more compact syntax as follows. Lastly, let's write all of the arrows on the same line. So this is the shortened version of this part here. We simply don't need to have the handler variable if it's just returning the handler variable. We can use the same trick to define event handlers that set the state of the component to a given value. Let's make the following changes to our code. When the component is rendered, the 1000 button is created. So rather than passing in static hard-coded string values, we're actually using a state this time. So it's 1000. The event handler is set to a return value of set value 1000, which is the following following function. The increase button is declared as follows. The event handler is created by a function called set to value plus 1, which receives as its parameter the current value of the state variable, value increased by 1. If the value of the value variable was 10, then the created event handler will be the function this. Using the functions that return functions is not required to achieve this functionality. Let's return the set to value function, which is responsible for updating the state into a normal function. Yes, so now we've gone back to not using the factory. We can now define the event handler as a function that calls the set to value function with an appropriate parameter. The event handler for resetting the application state would be reset. So setting it back to 0. Choosing between the two presented ways of defining your event handlers is mostly a matter of taste. Okay. So let's change this into this app, and then we can just remove these two components from the previous app. Cool. Okay. So we can move on to the next section, passing event handlers to child components. Let's extract the button into its own component. Okay. So we add a button component, and then we use the button component that we've extracted. Using the button component is simple, although we have to make sure that we use the correct attribute names when passing the props to the component. So text is here and set to value is here. Do not define components within components. Let's start displaying the value of the application in its display component. We will change the application by defining a new component inside the app component. Okay, so this is what we shouldn't be doing. So if we define a new component like this, and then render it with the value here, let's see what happens. The application will still appear to work, but don't implement the components like this. Never define components inside of other components. The method provides no benefits and leads to many unpleasant problems. The biggest problem are because React treats component defined inside another component as a new component in every render. This makes it impossible for React to optimize the component. Let's instead move the display component to its correct place, which is outside the add component. Okay. Yep, okay, so the app works. Oh, wait, what's happening here? Why is the app not working? Okay, let's do some troubleshooting. Why is it not working? So if I go here, is it running the set to value function? No. Why is it not working? Let me check. Something's not quite right. Props.value. I think I know why. So this should work now. Yep. It will start returning a function instead of executing a set to value. Okay, so we have some useful reading. The internet is full of React related material. However, we use the new style of React from which is a large majority of the material found online is outdated. You may find the following links useful. The official React documentation is worth checking out at some point, although most of it will become relevant only later on in the course. Also, everything related to a class-based component is irrelevant to us. Some courses on egghead.io, like Start Learning React, are of high quality, and the recently updated Beginner's Guide to React is also relatively good. Both courses introduce concepts that will be introduced later on in this course. Note, the first one uses class components, but the later one uses the new functional ones. Web programmer's oath. Programming is hard, that is why I will use all the possible means to make it easier. So this is something that was introduced in the beginning of the curriculum. I will have my browser developer console open all the time. I will progress with small steps. I will write lots of console.log statements to make sure that I understand how the code behaves and to help pinpointing problems. If my code does not work, I will not write more code. Instead, I will start deleting the code until it works, or just return to a state when everything was still working. When I ask for help in Discord, in the course in Discord channel or elsewhere, I formulate my questions properly. See here how to ask for help. Utilizing large language models. Large language models such as ChatGPT, Claude, and GitHub Pilot have proven to be very useful in software development. Personally, I mainly use Copilot, which is integrated seamlessly with VS Code thanks to the plugin. So because I use VS Codium instead of VS Code, I have chosen to use Windsurf instead. So, for example, you can ask Windsurf to explain set to value, and here it will start doing its thing, and this is what is generated. This is a function named set to value that takes a new value as an argument. When called, it logs the new value to the console and then updates the state by calling set value with the new value. Set value is likely a state update function from state hooks such as useState. Yep, that is the case. It is in fact a useState hook from React. Yes, so there are quite a few options. I think for VS Code, Copilot is probably the best way. Because I use an open source version of VS Codium, I use Windsurf instead. So Copilot can be asked to generate code for an opening file by describing the desired functionality of the text. Add a button that will reset the left and right. If the code looks good, Copilot adds it to the line. In the case of our example, Copilot only created a button. The event handler handle reset click is undefined. An event handler may also be generated by writing the first line of function. Copilot offers the functionality to be generated. In Copilot's chat window, it's possible to ask for an explanation of a function of a painted code area. So I think Windsurf should be able to do the same. Yes. The JSX code snippet renders a div containing display component and 3 button components. Yep, so you can essentially do the same thing with different large language models. Copilot is also used in error situations by copying the error message into the Copilot chat, and you will get an explanation of the problem and a suggested fix. Copilot's chat also enables the creation of a larger set of functionality. The degree of usefulness of the hints provided by Copilot and other language models varies. Perhaps the biggest problem with large language models is hallucination. They sometimes generate completely convincing looking answers, which, however, are completely wrong. When programming, of course, the hallucinated code is often caught quickly if the code does not work. More problematic situations are those where the code generated by the language model seems to work, but it contains more difficult to detect bugs, like security vulnerabilities. Another problem in applying language models to software development is that it is difficult for language models to understand larger projects, e.g. to generate functionality that will require changes to several files. Language models are also currently unable to generalize code, i.e. if the code has, for example, existing functions or components that the language model could use with minor changes for the requested functionality. The language model will not bend to this. The result of this can be that the code base deteriorates as the language model generates a lot of repetition in the code. See more AG here. So that's probably like a useful article to describe what's happening with too much reliance on language models and having the code quality deteriorate. When using language models, the responsibility always stays with the programmer. The rapid development of language models puts the students of programming in a challenging position. Is it worth and is it even necessary to learn programming in a detail level when you can get almost everything ready-made from language models? At this point, it's worth remembering the old wisdom of Brian Kernighan, co-author of the C programming language. Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? In other words, since debugging is twice as difficult as programming, it is not worth programming such code that you can only barely understand. How can debugging be even possible in a situation where programming is outsourced to a language model and the software developer does not understand the debug code at all? So far, the development of language models and artificial intelligence is still at the stage where they are not self-sufficient, and the most difficult problems are left for humans to solve. Because of this, even novice software developers must learn to program really well just in case. It may be that despite the development of large language models, even more in-depth knowledge is needed. Artificial intelligence does the easy things, but a human is needed to sort out the most complicated messes caused by AI. GitHub Copilot is a very well-named product. It's Copilot, a second pilot who helps the main pilot in an aircraft. The programmer is still the main pilot, the captain, and bears the ultimate responsibility. It may be your own interest that you turn off Copilot by default when you do this course and rely on it only in a real emergency. Okay, so here is the exercises. I will continue this in the next video. Thanks for watching. See you soon.